Hello, my name is Robb Boyd, and this is an ExplaiNerds podcast. Welcome to part 2 of 2 in our NCS 500 Innovation in the Access series. Part 1 covered the state of the access network, emphasizing the twin realities of the challenges to overcome and the bigger opportunities that it all represents. The advent of 5G requires quite a few changes for mobile service providers, and these changes make it possible for all service providers to reduce the variety of devices and protocols being used. This simplification means that new markets like business Ethernet and many others can all be accomplished on the same network, thus stretching efforts and investments in ways previously not possible. I encourage you to listen for all of this in part 1, of course, as we covered the specifics on the NCS 540 and 560 series, the benefits of using iOS XR end-to-end, and the ease of use this brings with segment routing and EVPN. And now in part 2, we are digging into the architectural changes this makes possible, as well as the options Cisco makes available for the investment required. The best way to understand where we are going starts with understanding how we got here.
'Cause no one can do it like we do it, like we do it, like we do it.
Radio towers have not changed all that much over the last, 3 decades of cellular data services, or at least cellular. In 1G and 2G cellular networks, base stations had an all-in-one architecture. All of the analog, digital, and power functions were housed in a single cabinet as big as a refrigerator. And the RF signal generated at the base there had to be sent up to the antennas at the top. Well, 3G and 4G networks brought us the distributed RAN, or DRAN, where the radio resource head, RRH, originally at the bottom now was taken out of the cabinet and moved up close to the antenna. Communication back to the base would then be happening over fiber running the CPRI protocol, CPRI, Common Public Radio Interface. These changes did not require any changes to the backhaul, which refers to the connection between the BBU, the base station, and the core data network. That's what we call the backhaul.
The backhaul is important as the new technologies are coming.
That's Prakash Daga, Director of Product Management in Cisco's Mass Scale Infrastructure Group, formerly called Service Provider Routing.
There's a lot of convergence in access network. The access networks have been built since 1990s, and every era has thrown a new type of technology. And right now, most of the telcos are having myriad of technology option on the access. Now, for a sustainable investment, it's not one-on-one backhaul upgrade, it's many-to-one, which means there has to be a convergence, and that's the only way service provider will justify the investment needed on any of these transport network, which is backhauling all the access back to the network. And when you talk about perspective of convergence, you need something which is extremely flexible, highly automatable, and has the capability to provide all the type of services. It's not just providing mobility services. They need to do mobility, residential. They need to do small and medium enterprises. They need to backhaul large enterprises. All the kind of services needs to be backhauled on that network. And hence, you need something which is Ethernet and IP oriented.
Now, because the coverage for a dense area can require thousands of radio towers, our insatiable demand for mobile data has pushed for even better efficiency. Some efficiency gains could be found within dense urban areas where the BBUs, those base stations from multiple towers, could all be co-located. But this only worked in certain areas as it required a longer distance, the front hauls, what that area is called. And that segment between those co-located BBUs were each connected with their own radio tower. And this was problematic because the CPRI protocol had to run on dark fiber, and so the distance was limited to just a few kilometers. To address this, the CPRI consortium published the eCPRI specification and defined how to carry radio signals over a packet network. This meant that the front haul could now work with your IDP, UDP, and or Ethernet. Making this work well, though, involves splitting the BBU, that base station, into two parts, centralized unit and a distributed unit. Now, the distributed unit, or the DU, can stay close to the tower, the RRH, which helps to avoid the efficiency issues that come with carrying high bandwidth radio signals on a packet network, something that's only going to increase with 5G. And this is how we now get a mid-haul segment. That's the segment that connects the DU to the CU, the distributed unit to the centralized unit. So here, there is no radio signal being carried on this mid-haul segment, so it offers more efficiency at a lower bandwidth, and now our less latency-sensitive functions can be moved further back in the network. So at first, this may look like things are now more complicated, but they really aren't. In fact, this is exactly how 5G network investments can drive simplification of more than just mobile, but all business services that a service may want to provide. But now you're driving all those services from the same network.
wherein we are defining this new front haul, as in the distributed unit to this radio resources, this specific part of the network. We are bringing in a newer solution which can help you communicate both in the radio communication with the radio base station there on one end, and you can also communicate with the rest of the packet network. Just get that radio packet as part of your Ethernet, add the Ethernet segment there, and then make it a typical IPOE packet, and then send it over the network. So that's the new thing that's possible.
This is Akshaya Kumar. He's a technical marketing engineer for Cisco's Mass Scale Infrastructure Group.
With this, the network itself is going to become scalable. You can keep your, the distributed central units at different parts of the network. It's just less complexity, if I may, and then more sophistication you can start adding to the network.
So NCS 540s can be used as distributed or centralized units. In other words, front haul, mid haul, back haul. That establishes consistency in the access network end to end. And a lot of these networks have historically been hub and spoke designs, kind of cobbled together with multiple products from various manufacturers. Well, now doing the converged all IP thing also enables several new architectural models.
So you can think of a simple spine leaf kind of an architecture wherein a service provider can have as many aggregation nodes, very high speed, 100 gig, 400 gig in the future kind of aggregation nodes. And now they can have this access nodes, and they can just have the single spine leaf architecture to cater any environment that they want. They can have the single fabric that can, on one end, it can talk to the mobile nodes and then bring in all the G node Bs in the 5G era, that is, or it can talk to the cable R5 equipments. It can get them transported to their central core network as required for the cable environment, or it can also talk to the business customers, build them the layer 2, layer 3 services. So each of these services, it required a silo separate network earlier, but now we can build this kind of a fabric, which is now possible because we can do a centralized controller or orchestrator and build a spine leaf fabric, because end to end it's an XR operating system running. It's very simple to manage, operate, and all that.
Now, generally, I think of a spine leaf or CLOS architecture being a data center thing. So why is this valuable in the access?
They want this ability to build this diverse access network. That should be low latency with respect to having the peer-to-peer communication that they want to build. So if it's two different radio heads that they want to talk to each other with the low latency requirement of 5G, what better way than CLOS architecture, which is going to give them just a one hop away irrespective of how far these nodes are. So they can have this spine layer, which will be like giving them the minimal hops. So if they have like multiple spine layers, which may be an option, then they may worst case have multiple hops. Or in most cases, as we see, it's going to be just a single hop away. So any two nodes, irrespective of where they are present in the network, if they want to communicate to each other. Again, going back, the 5G requirements, they want that 1.5 microseconds and all those craziness to make sure that they have that end-to-end low latency part. And now, from a service provider perspective, they also want to be able to scale out much easily. So if they want very high backplane bandwidth, they can add additional aggregation. So these are all things that CLOS architecture inherently brings.
So now scaling service attachments just means adding leaf nodes where needed. Each leaf can be a different port type, all of which ties to the same backplane.
Imagine a fabric in which you can have different flavors of these NCS 540s running together, each of them catering their different customer base. Like in that same fabric, you can have certain 540 form factors, which is more built for a mobile kind of a backhaul, that can also terminate, as an added advantage, some business customers. And on the other end, you can have certain form factors which will have more carrier Ethernet kind of ports and functionalities, and it can still, have some mobile, stuff too. So it's nothing like a hard, fast rule here, and that's the key idea. But it's giving them the flexibility of thinking a little bit widely and seeing what are all the different use cases.
It's important not to over-rotate on 5G enablement, because this same investment can support multiple business use cases like carrier or business Ethernet.
And what's actually more interesting is not just the attachment circuits for the mobile, business, and the carrier Ethernet, but we also see this edge computing slowly evolving. So if the customer wants to do some certain applications, video applications and all those, and which is all like very bandwidth consuming, and they can have some caching running very close to the customer, and again, that will be just one hop away. So this CLOS architecture kind of helps the service provider redesign the network just to cater to the new age requirements that we see with the videos and the high-speed video requirements and all those things too.
MEC, or edge computing, is the architectural principle of moving services to locations where they can have several things. Your latency reduction, so lower latency to the device for quality of experience. Edge offload, perhaps, for implementing offload for a greater efficiency. Or data reduction, where you perform computations there at the edge that augment the capabilities of devices and reduce the cost of transport. So edge examples include edge cloud, edge terminations, your CDNs, your AR, VR, automation, and APIs. There's just a ton of them. Well, back to the architecture and enablement for a moment. I want to cover off on a couple of 5G specific requirements, timing and slicing. And first, what is Class C timing support?
Traditionally, in Class A qualified devices or Class B qualified devices, when we have these devices introduced in a network, one of the key parameters that we always look into is the time error or the timing error that's introduced, which traditionally means there could be a plus or minus 50 nanoseconds, if I may, on a Class A. That's an approximate value, but it's close to that. And in a Class B, that could be about plus or minus 20 nanoseconds maybe. Now in a Class C, it could be further low. So what this essentially means is, if I'm trying to build a network between two different parts of my network, like the RRU on one end and then the other part of the network, all these timing aware devices or this components that in my network, all these things that may potentially introduce some latency, that has to be very minimal. And with Class C compliant devices, we can achieve that. So if a provider or an operator wants to build a 5G network, they have to make sure that they are having this minimal latency 1.1 to 1.5 microseconds. So you can think of the strangeness like 1.1 to 1.5 microseconds is like 1500 nanoseconds. And if I have to have this 1500 nanoseconds, and if you give or take all the other this delays, latencies that's going to be introduced by the fiber itself that's going to be laid or different components, you may end up with close to 300 to 400 nanoseconds maybe. I'm just again thinking out loud.
Yep.
On the actual infrastructure that you can lay. That number of nodes can be more if it's a Class C compliant device. So that's what that budgeting comes to.
Now, I did not realize the direction at first. So Class A and B are slower than Class C compliant timing, which is, of course, a must-have now for this part of the access network. And the NCS 540 is Class C compliant. So that addresses just one important aspect, though, of access networks being rolled out. Latency can also be a killer. I mean, imagine a critical virtual reality type application interrupted by jittery images and bad synchronization with the sound. So much for reality. Or maybe you're a gamer who randomly loses due to variations in the lag time you or your competitors are experiencing. Latency is highly dependent on distance, about 5 microseconds per kilometer. Most service providers have a centralized packet core where all traffic must pass before it can be broken down into a service. This is why it's so important to push the user plane deeper into the network and be as close as possible to the subscriber, all while keeping the control plane centralized. The application must be capable of reaching the end user quickly enough to prevent the degradation of the experience. Full stop. Network slicing and segment routing are key for the intelligent routing and traffic differentiation required to efficiently support this distributed architecture.
Now we can use segment routing based slicing of the network. Make sure that we prioritize certain traffic over the other. If I want a low latency carving for a certain radio traffic, I can build that also separately for using segment routing. And if I want a high bandwidth traffic for a very sophisticated 5G traffic that's coming in, I can also build that separately. So the segment routing helps me with the network slicing, which goes hand in hand with the 5G slicing from the radio end. So that's like how the architecture that we are going to build with the segment routing with the on top of this NCS 540 running the iOS XR is going to help with the end-to-end network slicing or the service provisioning for the 5G.
Well, that makes sense. Segment routing easily handles the network slicing. This is how operators can dynamically tailor the network based on traffic patterns and, as you said, specific customer use cases. So from the transport perspective, network slicing starts from the cell site router getting as close as possible to the radio. This is how we ensure service level agreements, or SLAs, run end-to-end from the cell site all the way to the packet core living in the data center. The transport slice through segment routing forms the basis of Cisco's X-Haul portfolio. X-Haul, of course, being the easy way to say mid-haul, front-haul, backhaul.
And since these devices can do all these protocols, CIFRI, eCIFRI, and Ethernet universally on all the ports, you can not just do 5G, but you can also bring in your traditional business customers, business Ethernet, carrier Ethernet, and all those things. on the places where it's deployed.
At this point, we've covered the technology, but now we must explore the financial realities under consideration. So the opportunity in the access layer involves infrastructure investments that go beyond simply addressing short-term needs. The promising news here is that Cisco continues to explore new ways in which these large investments can be tied more directly to the revenue they're expected to generate.
Let's say a customer really likes the box and they want to buy a bunch of our devices, but that means they need to get a CapEx budget from their purchasing department. Now, getting a one-time budget approval for a very high amount, let's say 20 million, 30 million, probably is not always easy.
Sairam Potnuru is a product manager with Cisco's Mass Scale Infrastructure Group.
Now, we have seen is that customers prefer if you have a kind of a pay-as-you-grow approach where they can start with a lower capacity, so which means they're not paying for the whole box. They're only paying for a certain portion of the box. So the initial spend is, let's say, 40%, 50% of the overall spend.
The Flexible Consumption Model, or FCM, is an iOS XR-based approach to buying service provider routing products, which gives customers the flexibility to manage capacity in their network.
Now we are talking about ASR 900 to NCS 540 kind of a transition point, or the 5700 migration from 5500 and so on. All of these are where we are basically at a point where customer needs to make the transition from a previous hardware to a newer hardware, and he doesn't get any credit for the money that he's already spent on the previous hardware, right? So you purchase something and it's gone. There's like literally it's gone the drain. It's like a sunk cost, and you again have to buy few years down the line when you want to upgrade your infrastructure.
Based on Cisco's smart licensing solution, FCM simplifies the way licenses are managed network-wide. Customers can start with a minimum fill rate and easily add to the network as needed. Capacity is added to a network-wide pool, and extra capacity licenses can be used by any flexible consumption node in the network that requires additional capacity to meet demand. This means lower upfront costs and network-side license pooling. Software innovation, investment protection through software portability, they are all included as part of this new model.
Now what FCM does, it gives you investment protection. All the money that you've spent for your software gets moved to your next generation hardware. So let's say I, as a customer, spent 10 million on my software over a period of 3-4 years or whatever, and now I'm moving to a next generation hardware. I don't have to spend that 10 million again. I get the software corresponding to the 10 million for free. You only buy the hardware. Obviously, hardware is a completely new, you still have to buy the hardware, but the software comes for free. Now, that's obviously an advantage for the customer, right? Because you're giving them investment protection. Now, how does it work for Cisco? Typically, when you are going from one generation to next generation, your capacity requirements will at least go double. So today you're using 100 gig, tomorrow you'll use 200 gig. So which means maybe I'm giving the 100 gig bandwidth free, which they purchased in the previous hardware. I still have the next 100 gig that I can monetize. So from Cisco's point of view, I'm not giving the entire software for free. I'm giving like half of it for free. The other half I can still monetize. From the customer point of view, I'm not paying for the whole software again. I'm only paying for half of it because I'm getting some from my previous investment.
The flexible consumption model includes iOS XR software innovation to keep your network on the cutting edge with ongoing feature development that helps provide differentiated new revenue-generating services. Cisco's flexible consumption model goes beyond the basic per-box model, allowing for a true network-wide pay-as-you-grow model that also supports software portability for investment protection. This provides more visibility into the network and gives customers the power to quickly move licenses to areas of demand.
All of these things add up to the benefits, right? So the fact that we are giving an option to start with lower pricing, the fact that we are giving them software investment protection, the fact that we have changed the model into more of a software and less of a hardware pricing, which also means that their investment protection is even better. Then finally, we are also give them this license portability or license pooling. Instead of having your software license attached to a specific device, it's more at the network level, which means if Verizon has bought 10,000 licenses from Cisco, Cisco doesn't care which device you use those licenses in. You can use them in any device at any time. So it's like having a Netflix subscription, right? So I could use it on my mobile or I could use it on my laptop, and I could change it tomorrow. So today I use it on my mobile and tomorrow I'll use it on my laptop. It's not tied to a device. A smart customer who knows how their devices are going to be used can use this benefit to decrease their software cost.
So look, from pure business consideration perspective, as the next generation services are expected to evolve, say around 5G, around new residential upgrades, the investment required just on the end equipment, which is going to be huge and staggered over several years, right? Like it's not just a network investment; it's an investment over several components. Right?
Strategic investment, it feels like, yeah.
Yeah. And then during such disruptive times, I think it's critical to choose the vendor partners from long-term perspective. Like the three, which in my mind comes. One is investment in innovation, like a partner who has right amount of investment going on in innovation. The scope of innovation in 5G space is huge, right? It's just starting, and it'll happen over several years. It's not like what happened in 2020 or 2021. It's going to happen over several years. It's going to be iterative as well, right? Hence, it's critical to partner with vendors who have financial strength to continuously invest in innovation. So that's one, investment in innovation. Number two, if you just look from consumer and business convergence perspective, 5G services will likely enable providers deliver both residential and enterprise class of service from the same network, right? Hence, it will be critical to partner with vendors who have strong portfolio across the domain, not just say a specific domain. You have to have a partnership with a vendor who can bring everything together, right? And lastly, someone needs to look at financial viability of the company they're partnering with as well, because 5G investment will be a multi-year with new services developing. There's a lot of iteration left on 5G, making 5G successful from a consumer perspective. How much, what's the ARPU from the consumer? Because that's what finally matters. I strongly believe because the cost of operation and the cost of services which a provider can give to customer could be hugely different if you modernize the network and modernize the way the IP Ethernet is going. So the cost is hugely different, and hence from purely business consideration perspective, this will give a competitive advantage to any provider who is modernizing their network. Cisco has been in this space for, I would say, roughly about 8 to 10 years. It is not a new space for us. It's just an adjacency which we always had. We've shipped over 1 million devices in these many years, right? It just so happens that our focus have always been around Ethernet and IP. You know, the influx point of when the business case of Ethernet IP becomes extremely strong is actually right now.
Cisco is well prepared for what is now recognized as a very key inflection point. The NCS 500 series offers the best chance to simplify the furthest reaches of the network and potentially complete an end-to-end automation that may have seemed previously impossible. I want to thank our subject matter experts, Daga, Sairam, and Akshaya, of course, Fred Trait. I've included a few links to more information below. I thank you so much for joining us. My name is Robb Boyd, and you've been listening to an ExplaiNerds podcast.